Hello, welcome to Mr. Swords class, and today we're going to be talking about how can I use the chemical formula to identify its parts. We're going to be looking at, well, what is a chemical formula and how chemists have created a system that tells me not only how many elements there are in a particular compound, but also how many compounds or molecules there are in a reaction. We're going to use this to eventually look at how we balance chemical equations down the road in this unit, and so it's very important to get the basics right with balancing, and that helps us with chemical formulas. If I were to equate chemical formulas to anything, it's basically texting for chemists. What you're looking at here is you have different abbreviations for things because it got too long to write those ridiculous long elements like hydrogen and oxygen, beryllium, and writing all that out for a chemical reaction was getting very tedious. So they created a system that they used to not only tell us how many elements are in a molecule, but also how many molecules there are in a given reaction. And there are three parts that we're going to be discussing that help us to identify what is what in a chemical formula. First, we need to know what the main part is, and so the main part of it is the molecule. And so a molecule, by definition, is when two or more elements are chemically combined. This is slightly different from a compound because it's two or more different chemicals combined. A molecule can also be something like O2 or H2. These are not compounds, but they are molecules. So it's important that we make that distinction here. But that's another lesson, another place. But this just tells us what's in the molecule, and this is what it is. And now there's this little number here. It's called the subscript, and sub means lower, so it makes sense that this is the lowered position. The subscript tells us how many oxygen molecules there are, or how many of the element it's displaying on the left-hand side. And so if I look at Na, there is no subscript there. What that tells me is that there's only one of it. They got tired of putting Na1, H1, and all those things there, and so they decided, let's just drop it and assume that if I have one sodium element, I am just going to leave it blank as far as the subscript, and that just means, obviously, there's one there. And so if we have anything other than that, like a 2, 3, or 27, anything like that, we have to write it there. So this tells us that there is one sodium molecule or element, and then there's two oxygen elements. Finally, there is what is called the coefficient. And so what this tells us, it's always the number, the big number on the left-hand side. And what this tells us is it tells us how much of the molecule we have. And so in essence what that tells me is if I have 3 of whatever our molecule is. So 3m, I guess. If I were to think about it in math, it'd be just, using parentheses to multiply a quantity by a certain amount. So 3 times the quantity there. What's also important to remember is the layout of the elements. I always need to remember to capitalize the first letter and lowercase the second. And this helps me know when one element stops and another begins. If I look at my example here, down here I see that PB with a lowercase b is lead, whereas P capital B is 2 different elements. It's important to follow those rules in order to make sure that I don't mix up 2 different things and 2 different elements as opposed to one. So now let's take this into perspective and let's practice a little bit. I see 3H2O. What I need to remember first is, well, what are the elements in water, H2O? So I have H and I have O. And by itself, if I were to forget that the subscript ever existed, I would have to look at the coefficient here, or the subscript, and this tells me that there are 2 hydrogen and, since I see a blank there, 1 oxygen. But what this tells me here is something that I have actually 3 H2O. So by myself right now, if I don't have this coefficient, I have HHO, 2 hydrogen, 1 oxygen. However, if I have 3 H2O, I actually have 3 groups of H2O. So it's kind of 3 times the quantity, very much like that. Let's take a look at this problem right here. I got 2 CO2. This tells me I got carbon and I have oxygen. And by itself, I don't see a subscript, so that means I have 1 carbon and 2 oxygen. So I put 1 and 2, but I see a 2 there. So that coefficient tells me I have 2 groups of this. So I'm just going to multiply whatever I have when I have one group by 2. So since I have 1, I'm going to multiply times 2, and I'm left with 2 carbons, and I'm left with 4 oxygen. You see how I multiplied it by the coefficient? It doubles there, and so that's how I would figure out I have 2 carbons and 4 oxygens. The next problem I want to work with is PBS. I see no subscripts, so by itself I see PB, and I have S, and since I don't see any subscripts, that means I have 1 PB and 1 S. However, this coefficient tells me I multiply it by 4, so I'm left with 4 PBs and 4 S's. Now this final problem adds one little thing to it, and I want you to look at this. If you have to rewind this again to watch, please do. But if you want to look at this here, it's telling me here I got S2O4, and I see a parentheses there. What that's telling me is this quantity, there are 4 of this quantity. So it's almost like a coefficient, except it's within the molecule. So it's very important that I remember that. And it's like I take this section right here, this group here, and I multiply it by the subscript 4. So I'm going to do the same thing, except I'm multiplying a quantity. Now I don't see a subscript for PB, so I'm left with, I don't see a subscript for PB, so I'm left with 1 of those. But then I look, I see S2, but the quantity is multiplied by 4. So I have 2 times 4, and I'm left with 8 of those. And then to finalize it, I have no subscript for O, so I'm going to put a 1 there. I have 1 times 4. So I have 4. So that would be how I would tackle this. I got 1, 8, and 4. This parentheses works very similar, except I'm multiplying by the subscript on the right. To finalize, to review, the subscript basically is the lowered number, and so I see with H3, my subscript there is the lowered number 3. The coefficient is the big number on the left-hand side, and that tells me how many of H3CO there are, and so I have 5 as my coefficient. And the molecule is the elements and their subscripts. So the molecule in general is H3CO. So there you have it. These are the parts of a chemical formula. Now I will have you work on the Google Doc to give me any questions. Please rewind this, fill out your notes, and you can practice a couple on the back sheet there if you would like to. If you have any questions, put it on the Google Doc, and I will be sure to answer those in class tomorrow. Take care.